Good afternoon. This is Algebra 2, Lesson 8.5b. The homework is due on Monday. And if you have your phones out, just go ahead and put those into a bag. Let's get started. Here we go. You're welcome. So, this idea of solving exponential equations by rewriting them with the same base is something I'd be interested in knowing if you've done this before. Like, for example, I think we can get, and here's a new code, lowercase b equals 3. I want to rewrite this equation so that all of the exponential expressions have base 3. Because if the bases are equal, then the exponents can be equal, and we can just ignore the bases. We won't have to use log form. We'll just write these both as base 3. Well, the left-hand side is already an exponential expression with base 3. But 1/9 is not. So how can I rewrite 1/9 so that it has a base of 3? Or in other words, 1/9 is 3 to the what power? Raise your hand if you think you know the exponent that we could place on 3 so that taken together, 3 to that mystery exponent gives you 1/9. Please tell a fellow group member what you think the exponent is that you would place on 3 to obtain a value of 1/9. Then raise your hand if you think you know what it is. Owen, go ahead. -2 is Owen's answer. Raise your hand if you agree that 3 to the -2 is the same thing as positive 1/9. How can that be? 3 to the -2 is the same thing as positive 1/9? Well, it's true. That really is the right thing to do. So the code for that is we want to rewrite both sides so that the base is equal to 3. Okay, once you get the bases the same, then the exponents can be the same, and therefore we can write not the original equation, but the exponent equation. Our second and final new code for the day is EE. The idea is that if the bases are equal, if the bases are both 3 or 4 or 5 or whatever we get them to both be equal, then the exponents must be equal. So if the exponents are equal, that means that 2x minus 3 has to equal -2. So we're able to solve an equation where the variable's in the exponent without having to resort to using logs. That's the advantage of this new approach called the same base approach. Let's just rewrite the equation so that the bases are the same on each side. Now it's fairly straightforward. We're just going to do the old A3 and D2 routine. In fact, I'm going to do them both on the same line. I'm going to use a double code here. Adding 3 gives me 1 divided by 2 gives me 1/2. I believe the answer is 1/2. If you plug a 1/2 in for x, you'll see that half of 2 is 1. 1 minus 3 is -2. Sure enough, 3 to the -2 is 1/9. This is correct. Now, that's our first example. If you want to write your answer in set notation, you can do that. It's optional, but you can write x is an element of the set 1/2 or 0.5. Any questions on our first example?
Sure.
Now, it appears that, yes, question?
Yeah.
Go ahead.
So B3, since it is like it's our code, right? So let's say the equation was 2x minus 3, that's the exponent, equals like 1/6 or something?
Yeah, then we won't be able to use the same base approach. The same base, so the question, for those of you who didn't hear it, Gerald's asking, well, what if it were, instead of 1/9, what if it were 1/6? Would there still be a hope of getting both sides having a base of 3? The answer is no. This approach only works when the problem is somewhat pre-cooked, where it's set up ahead of time so that you can put it into the same base form. In fact, the ones on the homework get a little bit harder than this, and so I'm going to add another problem here. We have the room for it. Try this one, right? 25 to the 3x minus 1 equals 1/125. This is an equation that's more, well, it's actually at the level of difficulty that you'll encounter on the homework. This first one is not hard enough to really represent the challenges that you'll encounter on the homework. I think that I can rewrite this equation so that both sides have a base of, well, you tell me, what do you think there's hope for? It's not gonna be b equals 3. What do you think I can get the bases on both sides to equal? Jonathan? Yeah, there's actually real hope of getting a base of 5 on both sides. Like, for example, 25 is 5 squared. So write 5 squared parentheses to the 3x minus 1. 125 is also 5 to some power. What would that exponent be on 5, so that 5 to that mystery exponent would be equivalent to 1 over 125? Does anyone see that one? It might be an aha moment for you. It's like, oh yeah, I know what exponent we should put on 5. So that 5 to that power is equal to 1 over 125. Raise your hand if you think you know what exponent I should place above 5. Jay?
Would be to negative third.
Negative 3 is correct. Good work. Now, this one, I should simplify it using raise multiply. Before I write EE as my code, I'm going to simplify the left-hand side by distribution. I mean, raise multiply to multiply the exponents by distributing a 2 across the 3x minus 1. So the new exponent now is going to be 6x minus 2 equals 5 to the negative 3. So notice that the bases are the same, and I'm ready for the EE code, where EE stands for the exponent equation. This is not the original equation, but it's another equation that emerges using the logic that if the bases are equal, if the bases are both equal to 5, then the exponents must be equal to each other also. Otherwise, what would be the point of, in fact, that's just a proper interpretation of this equal sign that was given to us in the original problem. If they're really equal, and the bases are equal, then the exponents had better be equal. Go ahead and finish solving the equation with A2D6. So I really hope you come up with, let's see, after A2 it's negative 1. So it's going to be negative 1/6. Any questions on how to solve the equation to get x is an element of the set negative 1/6? Looks like we're in good shape. So to respond further to Gerald's question, what we see here in example 2 is an example where the same base approach is, there's not a lot of hope there. So we're just going to go without trying to get the same base. Like, for example, if in example 2 you subtract 2 from both sides, we get 8 to the x equals 3, but it's like there's no nice way to rewrite 3 in the form 8 to some power, and so we're not even going to try. Instead, we're just going to do what we've done in previous sections, and that is we're going to write this in log form. So go ahead and write this exponential equation in a logarithmic form, and when you're done, take a peek up here, see if we agree. So we didn't get the same base, but we still solved it. We got x is log base 8 of 3. And by the way, it says, so that's what we call the exact answer. If desired, use your calculator for an approximate answer. So let's do both. Let's use wavy equals. And if you're absent yesterday, then good news. We can just do the calculator work that we did yesterday. Yesterday, what we did was in mode, we went into math print of all things. And then we did log base 8 of 3 using the command alpha window 5. Alpha window 5 in math print enables you to quickly enter log base 8 of 3 with ease. We discovered that log base 8 of 3 is approximately 0.528, well, to the nearest 10,000th, that would be 0.5283. So, 0.5283. Any questions on that one? Hello. Now, all right, I'm just gonna